Hey everyone, welcome back to hok'stutoring. So this is a continuation from the previous topic video. If you haven't seen that video, I recommend you check it out before you watch this video, as that explains all the details of the concepts and the application of what I'm about to do here. So anyway, let's get into the question. So the first question is anti-deriving x multiplied by x squared minus 3 to the power 5 in terms of x. How would you derive that? Well, there are two functions over here, x and x squared minus 3 to the power 5. And if you want to anti-derive this, we use simple substitution. How would you do simple substitution? The first step is you let u equals to the function, usually the ugly one. So one of them, right? So in this case, I'm going to let u equals to x squared minus 3. It's a bit of trial and error. You can, pick the other function and then you realize it doesn't work out. You try the other one. So in that case, u equals to x squared minus 3, we derive it afterwards, du dx, and that is equals to 2x. Okay, so I guess in the previous video I showed you this technique, so dx equals to du over 2x. I made dx a subject, but your teacher might do something differently, and the other method of doing it is you just find x by itself, so x would therefore be equals to half of du over dx. Okay, so I'll show you the two different steps methods. This one is what your teacher is most likely going to do. This one is just to illustrate to you a quicker way of doing it. Right, in this case, the first one right here, whoops, that is a bad integrand, that so we have x multiplied by u. I'm just going to replace x squared minus 3 with a u, but it's to the power 5, and then dx is now du over 2x, right? And then of course the x cancels out. That is the purpose of simple substitution. And then you're left with only u to the power 5 du, and then the half comes out over here, and that's pretty much the purpose of simple substitution, right? So you want only one function, and that function can be is a polynomial, so that you can anti-derive it. Okay, so that's pretty much it. If you want to use the other method, then it's very similar. Okay, so I have an x here. What is x equals to? It's half du dx. So I can write this. So x squared minus 3 is still u, is still to the power 5. But another way of writing x would be half du dx. So that's the same thing as writing x, because we found it here. And then of course we still have the dx, right? So that's the dx. And then you're left with the same thing. The half comes out. You still have u to the power 5. And instead this time the dx cancels out. And then you're left with du. And that is the same thing. So if you want to anti-derive this, well, it's half, open bracket, u to the power of 6, because we add the power by 1. Bring the power down but divide it, and then just make sure you put a plus c on the outside. So our final answer is 1 over 12. I'm just going to sub the u in, which is x squared minus 3 to the power of 6, and then plus c every time. Okay, so that's how you do this question right here. Moving on to part question C. So this is all question 1 of 7C of a textbook. So if you're struggling with that, hopefully this video helps you out. Once again, if you want to anti-derive this, it's not polynomials anymore, but it kind of is. You can still use simple substitution. I'm going to let u equals the function that looks the most complicated one, in this case sine x. Now you might be wondering, why don't I pick sine cube x? Well, if I pick sine cube x, deriving it is going to take a bit of effort. So I just want u equals a simple function, but the simple function is inside something ugly. Okay, so that's pretty much the case. Du dx equals to cos x, because if I derive positive sine, I get positive cos. Just be careful, do not anti-derive positive sine, and don't mix them up, okay? Because that's a common mistake for many special students. So if I derive positive sine, I get positive cos, and then I'm going to write dx by itself. It's going to be du over cos x. And what do you realize? Ooh, the cos x and that cos x, it's definitely going to cancel out, okay? That's the good news. So I'm just going to rewrite this in terms of u, cos x, and there we go. Our cos x cancels out, and then what you're left with is the antiderivative of u cubed in terms of u, and of course we know what that is. We get 1 over 4 u to the power 4 plus c. All you have to do is replace the u. So in this case, the u is sine x, so all I'm doing is I'm going to replace that. So we get sine x to the power 4, or you can write sine 4x plus c, okay? And that's pretty much for this question. Now for the last one over here, part M, once again, let u equals to the whatever function that looks complicated. So you have like a lot of choices. You can either let u equals 3x, you can let u equals 2 minus x squared, or you can let u equals to x squared. Up to you. I'm just going to do let u equals 2 minus x squared. And if we derive this, du dx will get negative 2x. And then dx would therefore be du over negative 2x. And you can already see that x and that x is going to cancel out. So I'm just going to write it here again. 3x over u du over negative 2x. I'm just replacing things, like making things in terms of u this time. And what we get is this x will cancel out. And you're left with negative 3 on 2. You can bring any numbers outside the integrand, okay? As long as it's a number, you can bring it out. And then you have 1 over u du, and there we go. It's negative 3 on 2. And as we learned before in the basic anti-differentiation video, if you anti-derive a hyperbola, you get a log. And in this case, log mod of u is 2 minus x squared. I'm just going to write it there. And there we go. Negative 3 over 2 log mod 2 minus x squared brackets plus c. And that's pretty much for chapter 7c, guys. Integration by simple substitution. If you're still struggling with this, make sure you leave a comment. Let me know what questions you want answered, or make sure to check out the topic video that I've done on this so that you can brush up on your understanding of that. But aside from that, guys, thank you for coming and watching this video today. I'll see you in the next video.